Okay, so we are going to talk about deviation of what? Light. We are going to talk about deviation of light. And mind you, this deviation we will discuss is on a single what? Mirror. In another video, we are going to talk about when you have two mirrors. So let's talk about deviation in a single mirror. So first things first, let's assume that we have a mirror. Okay, so this is a mirror. This is the coated part of the mirror. So this is the shiny surface of that mirror. Okay, now looking at this mirror now, can you tell me what this line represents? So I said a ray of light that strikes that mirror. What did we say we call it? Incident wave. Yes, you are there. It is called incident wave. And then when the wave strikes here, it will bounce back. What did we say we call this one? Reflected wave. Yes, beautiful. And then the third one at the middle, what do we say we call it? Normal ray. That is very, very nice of you. Okay, so but what happens before I do this? Let's see what really happens to that ray of light. Let's see what really happens to the ray of light. Now, when a ray of light strikes a mirror, the ray of light does not continue on its path. It does not continue on its path. Why does it not continue? Because the mirror is not a transparent surface. The mirror is not transparent, meaning that the mirror does not allow the light to pass through. But assuming the mirror would allow the light to pass through, it would have continued in that path. So it means that because of the coating on that mirror that blocks the light from passing out, the light has been deviated. Yes, now. So remember, when this is what will happen in real life. Okay? So in real life, when the light strikes the mirror, it will be reflected. This is what happens. Okay? So this is our normal ray. These are normal. But on a normal, what happens is that ray was actually what? Deviated. So this is the angle of deviation from here to here. This is the angle of deviation. So instead of the light to continue in this part, the deviation, look at the deviation that occurred in that light. So we are going to do a little bit of mathematics here, geometry, and we are going to use it to know exactly that deviation. So this is D, this is my deviation. Now remember from what we talked about before, angle of incidence, angle of reflection. Remember, this side is represented by I, angle of incidence. Again, this place is represented by what? R, angle of what? Reflection. Now, look at this line, is a straight line. This line is a very what? Is a straight line. It might not look straight to you, but I am trying to draw a straight line here. So what happens? So if I say I plus R plus D, because I, R, and D are on that straight line, they will sum up to 180 degrees. So the mathematicians, you can help me. You know that I plus R is plus D is 180. Reason is angles on a straight line. Angles on a straight line. Okay? Angles on a straight line. But we are not done. We need to recall. Recall from where? From the second law of reflection, that I is equal to R. That angle of incidence is equal to the angle of reflection. Yes, because I is equal to R, it means that anywhere we see R, we can put I there. So what will this equation become? I is still I plus R becomes what now? I. So I have I again plus D equal to 180. Oh yeah, let's continue our mathematics. I plus I is 2I plus D equal to 180. Remember, our aim is to find the angle of deviation. So D, make it the subject. D becomes 180 minus 2I. So this is our formula for calculating the deviation of light from a single mirror. So deviation is equal to 180 minus 2I. Don't forget that. Don't forget that. So the deviation from a single mirror, this is the formula to actually solve that question. Of course, D is your deviation. D is your deviation. And then I is your angle of what? Incidence.